Good morning, class. My name is Sergeant O'Brien. I'm going to be taking you through this block of instruction this morning. First off, I want to welcome you all to Cohen Hall. We're going to cover some safety stuff right now. In case of a fire, we're going to exit this room. We're going to go down the hallway and take a left out the back door. Once we get out that back door, we're going to form up on the other side of the street. Class leader, get accountability. Let me know. We can report that up. Next thing I want to talk is tornadoes. In case of a tornado, we are going to move out in the hallway, get in the fetal position, head towards the wall, protect our head and neck. Next is earthquake. If there is an earthquake, we are going to remain here in the classroom. We're going to climb underneath our desks. We're going to protect our head and neck. If there is an active shooter, we're going to exit this room. We're going to move down to the supply room in the back of the building. We're going to barricade ourselves inside and wait for the all clear. Environmental considerations. Though here in the classroom, there aren't a whole lot of environmental considerations. Here at this schoolhouse, we do recycle. So what you brought in with you, make sure you take back out. Make sure you put it in the proper bin. The risk assessment for this block of instruction is low.
Always low.
Okay, today, Army value is duty. Can anyone tell me how duty plays into what we do here at the schoolhouse? Private Hendren.
We have to be at the schoolhouse every day to perform our duty, and when it is complete, that's when duty is complete.
Okay, I like that answer. You have to come to school every day. That is part of your duty. It's your responsibility to be here. That's good. Now this week's operational variable is political. Can anyone tell me how political plays in to what we do every day here at the schoolhouse? Nobody? Private Rodriguez? How does political play into what we do here every day at the schoolhouse?
Well, political, well, I'm really not really sure on political because, not sure how it works at the moment, so.
Okay, so I'll do it this way. Political here at the schoolhouse, thank you, go ahead and have a seat. But political here at the schoolhouse, everything that we do, because we represent what?
United States.
The United States. We are part of the government. Everything we do reflects on someone else, correct?
Yes,
So here at the schoolhouse, if a bunch of unsafe acts or something happened here at the schoolhouse, how do you think that would look on the other end, on the civilian end? Bad, right? So it all falls into that political aspect. You start getting other people involved. Okay?
You're watching theFirearmsChannel.com.
Artillery has a noticeable effect on the battlefield, and to this fact, the 1st Battalion, 37th Field Artillery Regiment is no stranger. Top at the Yakima Training Center in Washington State, delivering precision fires on the minute, a task that involves an orchestrated dance of well-trained soldiers.
The step-by-step includes from 7 to 9 cannoneers to operate this weapon system. It requires opening and closing the breech, lowering and raising the tray, deflection and quadrant, ammunition preparation.
In this exercise, the M777 howitzer is suppressing an enemy position while maneuver elements move in to overtake it. The cannoneers must ensure the accuracy of their position to safeguard friendly troops involved in the engagement. I'm Army Sergeant Nathaniel Phillips, Yakima Training Center, Washington.
You're watching theFirearmsChannel.com.
Okay, our previous lesson was DA forms. We're going to move into titanium welding. That's what our current lesson is going to be. Now, I'm going to read. There is no assessment at the end of this, although there will be a check on learning using the e-clickers. So pay attention. And at the end, we'll do our little check on learning. The TLO, I'm going to go ahead and read this one to you. Action, communicate the properties of titanium. Conditions. In an operational environment, given a classroom, TC 9-237 modern welding book, student handouts, and supplemental training material. Standards, correctly describe all properties and characteristics of titanium metal on military equipment. Students answered all check on learning questions with 100% accuracy within 2 attempts. We're not going to need 2 attempts, right? Okay, good. All right, let me switch this one over real quick. Okay. Now, we're going to be covering titanium. Y'all saw the little video. In that video, it's a 777. That's what that piece of equipment is called. On the 777, the landing legs, or the frog legs, as they call them, are made out of titanium. So you may be called on at some point to repair that titanium. And you need at least the base knowledge on how to do that. Correct?
Yes, sir.
Okay, I gotta click on the screen. So yeah, the military has introduced new high-tech equipment to the soldiers today. This equipment is lighter, stronger, and able to withstand harsh environments that you will see in Iraq and Afghanistan. Some of this equipment is being constructed with titanium due to its superior characteristics over steel and aluminum. In this lesson, you will learn how to identify and properly repair titanium. Safety. Private Fleming, can I get you to read the safety for me?
Oh, sorry. Safety. Working with titanium causes a limited fire safety concern when small particles or surface grinding dust is generated. If fire starts in these materials, it is very difficult to put out. If small particles and shavings are covered with oil, they are even more flammable. Proper storage requires keeping the shaved particles and dust in a covered steel drum. Working with titanium causes no air quality problems.
Okay, very good, thank you. Now basically, what this is covering, anytime you grind or you file on titanium, the little particles that come out are extremely flammable. Extremely, they burn very fast for a good while. So if you are dealing with these, make sure that you don't catch them on fire when you clean your station. You put them away somewhere safe and secure so that they don't catch fire. Okay, so titanium properties. For the Private Conrad, let me get you to read that first bullet.
Titanium is a metal that may be used in a pure or alloy form. It has a silver gray look, looks much like stainless steel, and is very lightweight, approximately 1/2 the weight of steel.
Okay. The second bullet, titanium has the advantage of being one of the highest strength to weight ratios. Titanium has the ability to withstand corrosive environments, makes it the alloy of the future for many applications. Titanium is heavier than aluminum but lighter than steel. It is available in many forms such as forgings, bars, sheets, and plates. So you can get titanium in any standard metal format that is required. Okay? So, the spark test. When y'all went through your class before, they covered how to you take a spark, like you scrape the metal, and according to what color the spark comes off, that's an easy way to determine what type of metal it is. Well, when you do this with titanium, it's going to be a brilliant white spark. Really super bright spark that comes off of it. Okay, the easiest way to know what you're dealing with. The silver or gray color, that is the standard color of titanium. It's heavier than aluminum, but it's lighter than steel. You may not always be able to determine that because when you have it on a large piece, it's not always easy to pick it up. A magnet will not stick to titanium. So that's it. If you're at work, you're not sure if it's steel or titanium, pull out a magnet. One of the easiest ways to figure it out. Now, the biggest problem with welding titanium is the consistent problem of porosity. It takes a lot of inert gas to keep the metal clean enough to fuse properly without getting that porosity in your weld. Any grease, oil, debris, and anything that's on that metal will cause the porosity to come through. So, just like that bottom one says, it is super important anytime that you're dealing with titanium that you clean it. And you clean it with a stainless steel wire brush. That stainless steel wire brush is only going to be used for titanium. You do not use it on steel and then bring it to titanium or vice versa. When you have one, you use it strictly for titanium. Can anyone tell me why, Private Smith?
Sorry, the stainless steel brush is meant for titanium, and use it on cold steel, for instance, it would contaminate it, kind of contaminate the brush, and therefore if you tried to wire brush it on titanium, it would put particles onto the titanium that's not meant to be there.
Good, very good. Go ahead and grab a seat. Just like he said, if you take that brush and you use it on steel, it gets little pieces of steel in it. And when you transfer it back to titanium, you're getting little pieces of steel on your titanium, therefore it is contaminated. Very, very good. Okay? To prevent contamination of the weld area, protection weld zone provided by a high purity inert gas. What else uses a high purity inert gas? What other process of welding? How about TIG? TIG, right? Okay, titanium must be shielded from the atmosphere until it is cooled to below 800 degrees Fahrenheit. Now, there's a couple ways of doing this. You keep it shielded. You can use what we have here, which is a trailing shield, which allows the gas to steadily cover your weld all the way through on the back side, so it constantly has gas flow over it, right? Okay? The welding process requires bottom of the weld. Well, how do you think we're going to get shielding gas on top and bottom? Well, Private Rodriguez.
By using a lighter air, sorry?
Okay, good. Yes, you could use a lighter air. The most common thing that you'll see is a backing plate. Okay? So I'm going to pass these around. Y'all can go and just take a look at them. Be careful with the backing plate. It is heavy. I don't want anyone dropping that one, okay? Now, this is exactly what we're covering right now. So you have a backing plate, you have a trailing gas shield, and if it is possible, at any point in the perfect world, you would have a gas chamber. You would be able to put that part in, so you wouldn't have to worry about any of that. But we don't always have that availability to us. So this is going to be your most common setup. Now, titanium can be welded with two different processes. You can use TIG and you can use MIG. Can anyone tell me why those are the two processes that you can weld titanium with? Private Islip?
Because they both have the shielding gas, sir?
Correct. Go ahead and take a seat. Those are the two processes because you need shielding gas. The most common process that is going to get used is going to be TIG. Okay? So when GTAW welding, a 2% theorated tungsten is used with direct current electronegative. It has to be direct current electronegative. It's the same thing you use to weld steel. Okay? The arc should not be touch started. You're going to need to use your foot pedal. There is no scratch start. There is no touch start. a welding grade of argon inert gas free of moisture and impurities is required. So make sure that the gases that you're using are welding grade gases. Now, we're going to cover the weld colors, what you want that weld to look like. Okay? The best way that I know to explain this is I have examples. Okay, we have them welded up on this piece of titanium. I'm going to pass it around as we cover them, and y'all can see which welds are good and which welds are not. See, Private Paul, can I get you to read that first bullet for me?
Silver, bright like a new dawn, usually indicates correct shielding and sound non-contaminated weld.
All right, thank you. Go and grab a seat. So what you want to see is that bright silver, just like it says, a new dime. That's what you want to see when you finish your bead. The straw, so it's a pale yellow golden. It's except ductility. So it will hold, but it's not really suited for a high stress application. Make sense? Blue or purple is low ductility, unsuited for stressed application. You don't want to use that for anything. If it's holding any weight, that's good weld. It needs to be redone. And gray powdery is not acceptable. That weld is not going to hold. Okay, are there any questions over the colors? What color are we looking for? Silver. Just checking. To prevent overheating, there's a couple ways of doing this. Titanium is very sensitive to heat. So the best way to do it is you have your foot pedal, which you can back off of, your travel speed as you move across, right? This is all basic TIG operation, correct?
Yes, sir.
Okay. Intermittent welding, very popular way of doing it. You lay a small bead, you put some space, lay a small bead, put some space, a small bead, and that way it doesn't get a chance to heat up. So in conclusion, many grades of titanium can be fabricated, but they require more process controls. Carbon steel, more process controls over carbon steel and aluminum. The extreme care required for welding and weld distortion are the two biggest concerns in titanium fabrication. So, we're going to move on to our check on learning. I want y'all to grab your e-clickers. That center button, we'll turn them on. The very first question that we have up here is, what is the power source for titanium welding? Did everyone respond?
Yes, sir.
Good? Let's see what we got. 100% said 1. That is correct. Direct current electronegative is the power source. Very good. Move on to another one. What are the two types of gas used to weld in titanium? There's two different types that you can use, but you tend to use only one. Did everyone answer?
Yes,
Yes, sir.
Number 5, helium argon. Very true. Very true. You won't see the helium a lot because it's expensive, but argon, all y'all will have that in your shops. So, we just covered this one. What is the preferred weld color for titanium? The preferred weld color for titanium. Did everybody answer?
Yes,
Yes,
sir.
sir.
Okay. See what we got. 3. That is correct, 100%. Silver, bright like a new dime. Very good. The biggest problem with welding titanium is what? The biggest problem with welding titanium is what? Did anyone answer?
Yes, sir.
What do we get? Number 2, porosity. Yes, porosity is the biggest problem with welding titanium. Now, the ways to get rid of that is the gas, correct?
Yes, sir.
Okay, so that is correct. At this time, this includes my block of instruction. Everything that we've covered today was titanium. Your next block of instruction is going to be on depleted uranium. Does anyone have any questions? Right, thank you.